Hello, this is question 5 on your statistics paper from Edexcel June 2020, the AES paper. So you have hypothesis testing question. So Africa works in a call center. She assumes that the calls are independent and knows from past experience that on each sales call that she makes, there is a probability that is successful. She makes 9 sales calls and we need the probability that at least 3 of these are going to be successful. So we are going to call X to the number of calls that are successful, and that X is going to be a binomial. We are going to repeat the experiment 9 times, so N is 9, and probability of success is 1/6. So 9, 1/6. We need the probability that at least 3 are successful. We don't have this in the calculator. Remember, we have the smaller or equal, so we are going to rewrite this as 1 minus probability of X being smaller or equal than 2. And now we can go to the calculator. Binomial CD, because it's cumulative when it has the smaller or equal. Binomial CD, N is 9, P is 1/6, X is 2. And I have 1 minus 0.8217, and this is 0.1782 something. I'm going to round to 3 decimal places, for example. So this is the first one. Then for B, they say probability of Africa making a successful sales call is the same each day. Africa makes 9 sales calls on each of 5 different days, and we have to find the probability that at least 3 of those sales are successful on exactly one of these days. So we can consider another variable if you want, y, which is number of successful calls in one day, and we know that variable is going to be a binomial. We are repeating 5 the experiment 5 times, and the probability of getting 3 or more calls successful in one day is this one here. Yeah, is 0.178. So we are checking the probability that at least 3 calls are successful in each day when I check 5 days, and I need the probability that is exactly one of these days. So I need probability of y equals exactly 1. Remember, this is binomial PD, probability distribution, not cumulative. So I can go to the calculator straight away, and this is 0.406. Another way would be using the formula of the binomial, but I think this is faster and you make less mistakes. Yeah. Next thing, Rowan works in the same call center as Africa and believes he's more successful salesperson. To check Rowan's belief, Africa goes the next 35 calls Rowan makes and finds that 11 are successful. So we have to do a hypothesis test to check if that's true. So for that, we are going to write always the hypothesis. We want to know if probability of Rowan is 1/6 like Africa's, or as he claims is greater. Yeah, so it's going to be one tail, and it's going to be greater than, because he thinks he sell more products. So these are our hypotheses. If the first one is true, that is what we are going to assume. Our X is going to be binomial 35, because they are monitoring 35 calls, and the probability is going to be 1/6. And now we are going to do, I'm going to remind you that we have 2 methods to do that one. So the first one will be just checking what's the probability of getting the observed value of 11 or more in this case, because I have greater here. And I'm going to check if this is smaller than the significant level. So this is 1 minus probability of X being smaller or equal than 10. I can do again this with the calculator, and I have 1 minus 0.9768 something. This is 0.0232, which is smaller than the significant level, which is 0.05. Yeah, if it's smaller, what I'm going to do is reject H0. Yeah, reject H0. And when I reject H0, remember, I'm going to accept H1. So there is enough evidence to say that the probability is higher for row 1. So that means that row 1 is a better salesperson, or is more successful, not a better is more successful salesperson. Yeah, and so you should write a line concluding that row 1, there is enough evidence to say that row 1 is a more successful salesperson. The other option is using the critical region. So I can find the critical region, because some questions ask me to find the critical region. Is not the case, but I always can find it. So I need to know a number A, which is my critical value, such as the probability of being A or greater must be smaller than my significant level. I don't have tables for this particular binomial, but if you have tables, I would recommend you to do this on the tables because it's easier. But the 1/6 probability is not in the tables. So I'm going to do with the calculator. What you have to do is to go to binomial CD. So I'm going to use binomial CD in the calculator. I'm going to write N is 35, P is 1/6, and then I'm going to try values of X until I find the first one. Sorry, no, I cannot, I won't find this in the calculator. I have to rewrite the question first. So I'm going to write 1 minus probability of X being smaller or equal than 1 less, like before, smaller than 0.05. If I rearrange this, I have probability of X being smaller or equal than A minus 1 must be greater than 0.95. So now I can go to the calculator because I have this in the calculator. I didn't have this, sorry. When you go to the calculator, you have to try values of X until you find the first one that is greater than 0.95. That value with the calculator is 10, which means that A is 10 plus 1, right? Because that's A minus 1. So my critical region is going to be X greater or equal than A, and A is 11. So this is my critical region. If my observed value falls into the critical region, I'm going to reject. And that's the case because remember there are 11 sales successful calls. So that means 11 is in critical region. If it's in critical region, I have to reject H0 and accept H1, which is the same conclusion, of course, like I did before, right? So there is enough evidence to decide or to say that row 1 is more successful salesperson. Yeah, and that's all with this question.